Dear student, in this video we studied in the topic of spectrum. Actually, this topic there is a from the Bohr atomic theory. Okay, it's a Bohr atomic theory. There is a one of the postulates of it's a Bohr theory. Postulates of there's a Bohr theory that is for nothing but there is a spectrum. Okay, Bohr theory there is nothing but in the topic of spectrum. Okay, so initially we covered that the Bohr atomic theory in the previous video. If you want that video, that is present in our channel. Okay, so this spectrum is nothing but it's a spectrum that is nothing but it produced by passing the electromagnetic radiation through the prism. If you assume there is a prism, we pass through the electromagnetic radiation, the prism. There is the electromagnetic radiation or electromagnetic wave. This electromagnetic wave, when that fall in the prism, they have spread in the different colored, or there is a it produces a spectrum. Okay, so this is a spectrum. Okay, so the spectrum is nothing but it's from the electromagnetic radiation as well as the prism, or the electromagnetic radiation is passed through the prism. The spectrum can be gives actually the spectrum of waves in the decreasing or increasing order of wavelength or frequency. Okay, so we know that the electromagnetic waves, there is a cosmic wave, cosmic, and there is a gamma ray, and X-ray, and there is a UV ray, ultraviolet ray, and there is a visible, and there is a IR ray, infrared. IR means infrared ray, and there is microwave, and last one is a radio wave. Okay, so this also it's given in our channel of one of the video. Actually, those electromagnetic waves depend on that it can produce as a different kind of the spectrum. For example, UV spectrum, IR spectrum, and NMR spectrum. There is a mass wire spectrum. There is ESR spectrum. So those different kind of the spectrum analyzed from the organic compound, or even though the inorganic chemist of compounds. Okay. So that NMR, IR, UV, if you go to the higher studies, there is presented. Okay. So simply the spectrum is produced by passing the electromagnetic wave or electromagnetic radiation through the prism. The spectrum is arranged waves. There is in the decreasing or increasing order of the wavelength or frequency. We know that these electromagnetic waves, the cosmic has a highest there is energy. Okay, the energy of there is a cosmic is highest, but there is a wavelength, its cosmic is lowest. So what about that? The wavelength is highest. Very good. There is a radio wave is the highest. Okay, so there is radio wave as highest. Here is a energy of cosmic wave, electromagnetic radiation is highest, and in the case of wavelength, in the lambda value increases for radio wave. Okay, so we know that energy is inversely proportional of lambda. For that reason, there is those relations are appeared. See, the Bohr theory is applicable for only one electron species. Okay, so for example, hydrogen, helium plus, lithium 2 plus, etc. So because the multi-electron is a failure. So that is one of the limitation of the Bohr theory, and also that another limitation, the Zeeman effect and Stark effect, that cannot be explained the Bohr theory, and shape of the molecule, geometry of the molecule, that also cannot be explained in the Bohr atomic theory. Okay, so this Bohr theory is only one electron species is applicable. Here, the spectrum can be classified in two types. One is a emission spectrum. Okay, there is a emission spectrum. This emission spectrum, the highest energized object, they can be continuously emitting the radiation, or the discontinuous of a small packet or bundle of radiation is emitted. So if you assume this is the highest energized state, there is a accelerated state, the highest energized state of electron, they can be emitting the radiation. There is a microwave, or there is a radiation, it will become to the ground state. Okay, so for this radiation fall on that this any one of the electromagnetic wave. So if depend on that the electromagnetic wave, it can produce as a spectrum. That is a whether IR spectrum or emission of there is a atomic absorption or atomic emission spectrum. So those different kind of the spectrum is there. Okay, so this electromagnetic radiation is produced as the spectrum. If that spectrum or called, there is a emission spectrum. Okay, so suppose the another one category, there is a the absorption spectrum. Second is a absorption spectrum. this absorption spectrum actually, see, the lowest energy state, or there is a ground state of object or electron, whenever that absorbs the electromagnetic radiation, there is a radiation, it can promote it to the higher state of, that is nothing but excited state. So this absorbs the electromagnetic radiation is fall on that up to cosmic into the radio wave. For that, any one of the radio wave that have produced as a different kind of the spectrum. Okay, if like this, the absorbed radiation behalf of this producing the spectrum, there is nothing but the absorption spectrum. Okay, so here the absorption spectrum, the mostly the elements can be analyzed. For example, the rubidium, cesium, thallium, and there is a indium, gallium. So those elements are can be analyzed by this absorption spectrum. Okay, and the band spectra, or the band spectrum. This band spectrum is also called as a molecular spectra. Molecular spectra. Actually, we know that molecule, there is combined more than molecule combined more than two atoms, combined to become more than two atoms to become a molecule. Okay, for that reason, the atom is consisting the number of electrons. So the atom is combining the electrons. Similarly, there is a molecule it's made up from that the atom. For that reason, the molecule is containing the very huge number of electrons. Okay, there is a very high level of electrons are presented in that molecule. We know that the atomic spectrum, there is a very lesser amount of electrons compared to that molecule. So the absorption spectrum of the molecule, or emission spectrum of molecule, they have produced as a very broad line. Okay, that's like that. See, the very broad line, there is a there's nothing but there is a band spectra. Okay, there is nothing but there is a band spectra. If you assume another one type, there is a the C, there is line spectra. So this line spectra, there is nothing but there is a atomic spectra. The another name of atomic spectra, that is for there is a line spectra. We know that atom is consisting very lesser amount of electrons. That number of electrons transition or emission is very less. That's why that can produce as a very lean. There is a very line. It's like a stick, like that's a spectra appeared. Okay. Okay. Let's we go to that the atomic spectrum of hydrogen. Atomic spectrum of hydrogen. Okay, so we know that the hydrogen is consisting only one electron and one proton and zero neutron. So because we initially say the Bohr atomic theory is only one electron species applicable. For that reason, we can describe there is a hydrogen atomic spectrum. Okay, here there is a the hydrogen of atomic spectra. There is nu bar that is equal to 1 by lambda. Okay, so this one of the relation. So here the 1 by lambda is equal to R h rise base constant z squared atomic number, and 1 by n1 squared minus 1 by n2 squared. So this formula is very important. Okay, actually this entire relation, that's nu bar is equal to 1 by lambda is equal to R h z squared, that's 1 by n1 squared minus 1 by n2 squared. Okay, so this formula is very important for calculating the wavelength or wave number, whatever that there is a frequency, energy, whatever that they have asking the different types of questions. Here the R value as a rise base constant value, R is equal to, that is a 1097 678. That is a 1097 So it's like that, you can memorize or keep it in your mind. There is a centimeter inversion, or we can round out this value. There's a 109700 centimeter inversion. Okay, so similarly another one value, we can go to this 1.1 into 10 to the power of 7 meter inversion. Okay, so this value are very important for calculating the problems, because sometimes they are not given in the age based constant value. It's ourselves, we keep it our mind. Okay, next the hydrogen spectral line. Actually, see, this is the first line, that's n is equal to 1. So before or below this line, there is a nucleus are presented. Okay, so this first line, and that is a second line n2, and this is a third line n3, this is a fourth line n4, and this is the fifth line and this is the sixth line. Okay, n is equal to 6. This n is equal to there is a fifth line. Anyway, there is a this n is equal to 1 for this Lyman series. Lyman n is equal to 2, there is a Palmer series. N is equal to 3, there is a Parsons series. N is equal to 4, there is a Brackett series. And n is equal to 5, there is a P Fund series. N is equal to 6, there is a Humphrey series. Okay, so depends on that the energy levels, they have different names. In the case of the Lyman series or fall on the UV region. The Palmer series fall on the visible region. Okay, there's a visible region. So remaining this, there is a Parsons to Humphrey, there is a IR region. Okay, so that electromagnetic waves are produced such a kind of the line. We know that energy and wavelength, they have inverse relation. Here the maximum wavelength, there is a minimum of energy, as well as the minimum of wavelength, they have maximum energy. So in the case of Lyman and Palmer, energy differences as a maximum. So for that the lambda value as a minimum. Okay, so next there's a, if you assume as a Palmer series. Okay, if you assume as a Palmer series, the Palmer series as a visible region. It's a visible region. Visible, we know that with GR, violet, indigo up to there's a red, violet to up to red, there's a GR colors. Okay, so here there is a Palmer series n is equal to 2. N is equal to 2. I can return all everything. Here is a n1 and n2 and n3 and n4 and n5 n6. Okay, so here see the initially these two energy differences is highest compared to these two and these two and these two. The how increasing the n value, the energy as a quantized. Okay, so here the Lyman series, how much total lines or number of lines are obtained. There is n2 to n1, this one line, and n3 to n2, and n4 to n3, n5 to n4, n6 to n5. So like that they have lines are obtained. Okay, next the assume there is a Palmer series. Here the first line as alpha line, or that's a H alpha. Okay, so this appeared on the red color, and there is a second line, the second line as H beta line. So this line also called, there is a green line, okay. Suppose the spectral line is obtained is greater than n6, so suppose here, so that is nothing is there, so it is assumed as a n of infinity. So the n of infinity line is, that's called limiting line. Okay, that's a limiting line. So overall conclusion, there is a, the line is a maximum energy, lesser wavelength, and the maximum wavelength, there is a lesser energy, maximum energy, there is a lesser wavelength, and lesser energy, maximum wavelength. Okay, so the shortest line that is a shortest line formula, that is here lambda as minimum is equal to 12,400 divided by delta E of maximum, and there is a longest line here, lambda as a maximum, that is equal to 12,400 divided by delta E of minimum. Okay, and sometimes they have asking the total number of spectral line. The total number of spectral line, that is equal to that is n2 minus n1 into n2 minus n1 plus 1. Okay, n2 minus n1 into n2 minus n1 plus 1 whole divided by, that's 2. So this formula is essential to finding the number of spectral line. It's a simplify this another this formula, that is n into n minus 1 divided by n into n minus 1 divided by 2. So this formula is also very important. There is a simply n into n minus 1 divided by 2, or n2 minus n1 into n2 minus n1 plus 1 divided by 2. So this formula is very important to finding the spectral lines. Okay, so it's a very important and very easiest questions they have asking in the NEET and JEE level. We will see this unit of next content next video. Okay, thank you everyone. If you like in this video, you can subscribe and share your friends. Thank you.